Hello everyone. Now that it's time, so let's begin with the webinar. Good evening to one and all present here. Welcome to this webinar in which we'll explore the world of 3D model and design and how to design one using Fusion 360. And then we'll move on to make it smart and intelligent. First, let me introduce myself. My name is Amit Shiraria. I'm the Director of Research at Allskier, and I'm happy to introduce our panelists for today's webinar. First, we have with us the CEO of Allskier, Mr. Athar Tendulkar. Then we have with us our IoT strategist, Mr. Arjun Hariharan. After that, we have with us the system digitization member, Mr. Yashash Bhardwaj. And then we have with us the 3D modeler of our community, the 3D designer, the star of the show, and the person who is going to present this webinar, Mr. Mukul Yadav. So without any further delay, let me hand over to Athar to start off with the webinar with a few words. So over to you, Athar.
Yes, thanks a lot, Amit. Thanks for the wonderful introduction. So, hello everyone. Welcome to the webinar today on designing with Fusion 360. Your next 1 hour to have wonderful products being designed and your journey into the wonderful world of how do you model various products, how do you build it, and how do you make them intelligent. So we at Allskier always believe in this concept that everything the light touches is a product. Right from what you're looking at on the screen to the chair you're sitting on. Everything is a product which is designed by people who are just like you and me. So having said this, let's move on and take a deep dive into the wonderful world of 3D modeling and designing the future products for the industry. So with this, I would like to give it to Yashash for the further meeting. Thank you.
Thank you, Athar, for that amazing introduction. Hi, guys. My name is Yashash. A very good evening to one and all. So I'm going to talk about engineering and design and how engineering approach is important in our everyday life. So let me start by taking you through an engineer's journey. So when an engineer is employed in an organization or a company, they need to satisfy certain requirements. And apart from the obvious technical knowledge and general knowledge that they must have, which is quintessential, we as engineers need to think out of the box and try to, have the curiosity to learn new things. So the engineering approach is kind of tells you that an engineer is somewhat different from normal people. That's what differentiates between an engineer and a normal guy. Now coming to, let me just share my screen. I hope my screen is visible.
Yes.
So now coming to so now let me talk about the 6 phases or six phases of engineering approach to problem solving or the result. Now first comes ideation. Now without any idea or the concrete base, you cannot move on to the next step, that is the conceptual understanding of the idea. Now conceptual understanding comes with a lot of efforts, like going through a ton of research papers and going through a lot of literature, etc. Next comes planning. What is the plan of action? What the team members, what type of team members we need, etc. That comes under planning. Now, I feel design and development are the 2 most crucial in the 6 phases of engineering approach, because design and development are the 2 they are mutual. They have a mutual understanding, since designing for development is about finding the solution that produces the best possible user experience with least moving parts. So without design, you cannot move on to development. So what is development? Development basically comes with the software codes which you write, or making it more smart, making the device more smart. That comes under development. Now I'm going to talk about the design part. So your design may look very good on the surface, but the underlying code to create it could be a big mess, because that's what normal people see. Well, I see an application, I see a web application, and I say, oh, this is so beautiful. But the hard work which has been put into making that application, only people like designers, web designers, or any type of designers, they know what goes through to make such beautiful products. Now, going to the next slide. Now here you see two normal objects, like one is a non-living object and one is a living object. You can say, okay, what is the point? Give me a moment. Yeah, I hope my screen is visible now. So you might ask, why have I taken an airplane and why have I taken an eagle? Well, first of all, let me just glide through, let me show you the 3D models of these two. Now, nature and designers, we as engineering designers have a mutual connection. The connection is personal. So as you can see, a bird has wings, even the airplane has wings, and a bird is aerodynamic, even the airplane is aerodynamic. So we as engineers, we learn from the nature. We try to, there's a specific word for that is called biomimicking. So the wingspan has to be perfect. I don't know if you guys have wondered, but during my childhood, the air crash investigation serial, it was one of my favorite TV series growing up. So in that, while taking off, they say 40 knots, 60 knots, 80 knots, V1 rotate, V2. Well, that is for so that, you know, when the airplane reaches the particular speed, then only it can gather the particular lift. So the weight has to be proper, the symmetry has to be perfect. So that and all comes. So those are the most crucial aspects of engineering design. Now, as you can obviously say that design is like the backbone or skeleton of any model or project. Now, there are many softwares for achieving this models which you can design. One is Fusion 360, which in a while Mukul will be giving his insights into. And then you have AutoCAD, you have MATLAB, Simulink, etc. So those softwares are the ones which make these objects look beautiful. Now, I'll be handing over to Mukul for his insights on Fusion 360.
Right. Hello, everyone. I am so glad all of you could be here today. Before I begin, I just want to quickly tell you that I want you guys to take away the power of modern CAD softwares to literally be able to will something out of existence, to be able to design something. That's really powerful, and I believe it's a skill everyone should have. So without any delay, I'll now switch to my board to tell you something about the core concepts in Fusion or CAD in general. Yeah. So the first word that I want all of you to be familiar with is the word assembly. Right? Now, think of assembly as a collection of files that are incorporated in any design. And in assembly, there are two words that are really, really important, and I want you all to know about. The first word is bodies, and the second word is components. Now, this concept is really, really important because when people start off with Fusion 360 or CAD, they often don't know the difference between the two. And knowing this can really, really streamline your workflow and help you. So coming to bodies, think of bodies as simple 3D objects. 3D objects that are used for adding or removing any geometry. Whereas components can be thought of as folders or containers, right? And yeah, about bodies, in Fusion, we have solid bodies, we have mesh bodies, we have T-spline bodies. And last but not least, we have surface bodies. Now, for our purposes, we only need to know about solid and mesh bodies, which we'll see, right? And about components, I mentioned they are folders, containers. So what do they contain, actually? Well, they can contain bodies, they can have sketches, they can have other components. You could also have nesting, and they could also have joints. Joints allow bodies to move relative to each other. So I hope that the idea is somewhat clear, that bodies are more like files and components are more like folders. Bodies are 3D objects, components can contain bodies. Yeah. So now that we have a basic idea of what bodies and components are, let me take you through two major workflows that one can follow in Fusion 360 or any CAD software. The first workflow is the top-down workflow, and the second one is the bottom-up workflow. Okay. Now, coming to top-down, what we do is we start with an empty assembly file, and within that file, we model individual components on top of each other. We model components on top of each other, and all of these parts are linked. Whereas in the bottom-up approach, what we do is start with a bunch of pre-made components that we already have. And then we bring them together in a new assembly file and link them together manually using joints. Now you may wonder, when should I use top-down approach or when should I use the bottom-up approach? Well, in truth, they both have their advantages and disadvantages. The biggest advantage of the top-down approach is that meticulous planning isn't required. Since you are modeling all these components in reference to each other and on top of each other, you don't need to have an exact idea of how everything fits together because you can do so anyway within this empty assembly. Whereas in the bottom-up approach, you need to have a very planned, careful idea of how everything fits together so that the design doesn't fall apart when we actually start building it. Yeah, but being much more convenient, the top-down approach is also computationally slower. It takes a lot of time to apply an operation if your assembly is really, really huge. Whereas in the bottom-up approach, it's much faster, it's leaner. And this approach is recommended for pro engineers. Whereas if you're a beginner getting started, I would recommend the top-down approach. Let this sink in for a moment. And I hope that it's clear now that we can have top-down and bottom-up approaches. And I will demonstrate both of them in my workspace. In the meantime, please do answer this poll while I get settled. Right, so I see a lot of people are familiar with Fusion 360, then that's great. This will be interesting to watch for all of you. Okay. Right. Okay. Even for those who aren't familiar with any CAD software, I promise you'll at least take away the idea of what it actually is. Okay. So now let me start by sharing my screen. I'll share my Fusion 360 workspace. Yeah. I hope my screen is visible now.
Yes,
Okay.
Mukul, you're able to see.
All right. Okay, so this is what our workspace looks like. We have 3 standard planes. We have our 3 standard axes. And what I'll do is design a simple crude bike frame using the top-down approach. Just to make this a little easier for all of us, what I did was go ahead and import this canvas. This is just a canvas that will help all of you understand what I'm trying to do, right? So let's start. One important point to note is whenever we want to create a 3D object, it's customary to almost always start with a 2D sketch first. Yeah. So I'll do exactly that. I'll create a 2D sketch, but not before creating a new component. I'll name this component to be frame, and I'll click OK. Now that this component has been activated, I will create a sketch on the top plane, as you can see. Now, one really cool feature about Fusion 360 is we have something known as user-defined parameters. What they are just like variables in programming languages. So whenever when I'm drawing some geometry, instead of typing out the actual value of the dimension, I could just type in the length, the name of the parameter, and it would work the same for me. We'll see how this works in a moment. So let's get started with drawing a sketch. First, I'll create a few construction lines, starting at the origin. I want this to have the length of the bottom bracket offset, the BBO, has been already defined. Yeah, and you can see that it was defined to be 51.5 millimeters. I'll do the same, draw a few construction lines just for reference. Yeah. Now what I'll do is create a line meant for the seat tube, this portion. So let me start at this point and draw a continuous line. And I could dimension this to be so I could dimension this to be the seat tube. Yeah, now it's 450 millimeters. And don't worry about everything falling into place all at once. When we introduce constraints and more dimensions, everything will automatically fall into place. That's what's so interesting about Fusion 360. So let me now draw the line for the chainstay. Start at this point, and I want the length to be the chainstay. Yeah, and B, intersect the construction line. Now, one important point to note here is this line is black, whereas this line is blue. That's meant to signify that the blue line isn't fully constrained. I can click on it and drag it around, whereas the black line has no degrees of freedom. I cannot move it at all. The next thing I'll do is define the angle between these two lines. And I want this to be the STA, the seat tube angle. Yeah, and look at that. This line automatically adjusted itself to this angle. And now it's black. Let me now also connect these two for the seat stays. I'll arbitrarily draw the top tube and the bottom tube. They are blue. I could just drag them around. Let me also draw the fork. And now it's time to start constraining everything. So I'll start by defining this angle. This should be the FA, the fork angle. And the next dimension would be this height. This would be the handle height, defined to be 616. And last but not least, I'll define the wheelbase. Yeah, I will define the wheelbase. So now you can see the whole sketch has automatically fallen into place. And if we wanted to change some of these parameters, we could do so within the from the menu itself. So for example, instead of 1066, I wanted the wheelbase to be 900, say. I could do that, and the rest of the sketch would adjust itself to match what I wanted. Let's just keep it at 1066 now. Yeah. So now that our sketch in the top plane is done, I will finish it. But we also need two lines that I want to pass through the bottom brackets right here. And these have to be in the front plane. So let me create another sketch. Draw any arbitrary line of 100 millimeters. And I will now project points of interest for reference for commands such as draw, extrude, etc. I will fix it. And using this constraint menu, I'll choose whatever I want. So let's say, let's choose the midpoint constraint. I want this point to be the midpoint of this line. And I also want this line to be horizontal, to be vertical. Yeah, so now it's fully constrained. That's nice. I will finish my sketch. Now I want to draw a similar line through this point. Yeah. But the problem with that is we can only draw sketches in these in the standard front top planes by default. And this point is offset at some distance from the origin. So what we will have to do is first create an offset plane that's parallel to the front plane. And I want this plane to pass through our point of interest. Yeah. Now we can draw a sketch through it. No, not this. Create a sketch. Yeah, through this plane. And I'll draw a line of 125 millimeters. I will project points of interest. It's always good practice to project. And I'll use the fixed constraint. And then finally, the midpoint constraint. Yeah. And I'll just drag it around a bit and make it vertical. Yeah, so it's defined now. That's great. So now you can see that we have lines for the bottom brackets. But what I want to do next is create the lines that are meant for this seat stay right here. What I want to do is create a line that starts at this point right here and ends at this point. The problem with that is these two endpoints are not in the same plane. So I'll have to create a plane at an angle that passes through this line and angled like so. Yeah. Great. So what we'll do now is create a sketch. We'll use the project to project points of interest and click on OK. Let's use the line tool again, and let's dimension it to be 300. Okay, yeah. Okay, the next thing we want to do is create an arc, a 3-point arc. Yeah. Let's create a construction line for mirroring purposes. Cool. And now let's mirror this seat stay across the center line. Yeah, it's been mirrored now. And let's fix a few points to fully constrain the sketch. Yeah, so now we've fully constrained it. We can finish it. And this is exactly what I was talking about when I said I wanted a line that started at a point in one plane and ended at a point in another plane. So these are what our seat stays will be. I'll do the same for the chain stays. So you can see that there are really creative ways to get around issues in CAD. And it's all up to the imagination of the designer. Project, as always. Click OK. And create a line that goes like so. Yeah. Now it's 90 degrees. Let me fix, constrain everything. Yeah. Finish. Yeah. So now we have our skeleton ready, which we will use to create our frame. This is a sketch. And what we want to do now is turn this into a 3D model. And one of the simplest ways to do that is by using the pipe command. The pipe command creates a cylinder around a line that we can choose as its axis. So I will choose this line as the reference, and I want the section size to be 35 millimeters. And the operation, I will leave it to be new body. I want this to be hollow with a section thickness of 5 millimeters. This is indeed a new body now. Yeah, let me just turn that sketch back on. Yeah. And let me just draw your attention again to bodies and components. What I am highlighting over here is a component. Frame is a component. And within that component, we have bodies. Bodies are 3D objects, whereas components can have sketches and everything. I will repeat the operation several times. I will create more new bodies, more of the same. Repeat. Oh yeah, and we'll have to keep turning our sketches back on because operations often consume them. I repeat and create a new body. Repeat again. Create all these chain stays. Turn the sketch back on and use this. Create another new body. Finally, let's have our seat tube. And I want this to be thicker than the other. So I'll change the section size to say 50. Again, a new body. And finally, the bottom bracket. Let's have this at 35. A new body. Let's turn all these sketches off. So yeah, this is what we've done. We've created a very crude bike frame. And as you can see, there are a lot of finishing touches that could be done. So you can see that these pipes are, well, they're extraneous. There's a lot of extraneous material, right? We'll have to remove that. And this color in general is a little drab. You could also change its appearance by right-clicking on the component and changing its appearance. Let me search for paint. And let's choose green. Drag and drop. And there we have it. We have our green frame. So after a few more finishing touches, this is what we end up with. What I did was emboss a few letters, remove all the extraneous material, and create holes for mounting holes for the wheels. And I must point out that what I've been doing so far is using the top-down approach, because I started with an empty file and I created a new component within that. But what I'll do now is show you how bottom-up approaches work. To that end, I have a bunch of components that I've already modeled, and I will bring those in this design and connect them together, link them together using joints. I will start with the handlebar. Yeah, takes quite a while for load. Yeah, just move it out of position. Yeah, and I want to create a joint. So for joints, I'll click on the Assemble drop-down menu and click on Joint. And I want the first snap point to be over here, and the second snap point to be over here. We will also change the categories. If it's rigid, we could change it to revolute. That's what we want. So now you can see that we now have a revolute joint for the handlebar, and I'll click on OK. The next part that I want to bring in will be the front fork. Okay, let me move this out of position as well. And yeah, while working with Fusion, you may sometimes find that it's a bit difficult to choose or select components. So what I'll do right now is turn off the visibility of the frame by clicking on the eye and create a joint between the fork and the handlebar. I'll create a joint. This is the first snap point right here, and this would be the second snap point. And instead of revolute, I want this joint to be rigid. And click OK. And see, when I click and drag this handlebar around, you will notice that the handlebar and the front fork move in conjunction with each other, which is exactly what we wanted. I'll turn the visibility of the frame back on, and I will add yet another component. I will add this time the seat. Yep, yeah. And for the seat, I want to create a slider joint this time. So I'll do that. This would be the first point, snap point, and this would be the second snap point. And instead of a rigid joint, we want a slider joint. Click OK. Yeah. So joints, the rigid joint, the revolute joint, and the slider joint. After adding a few more components like the wheels and the sprocket, what we will get would look something like this. This is a, it's simplistic, but it does look rather convincing. This is a very basic model of a bike that I made. You can see that there are all these joints present in places where we link components together, and we can even animate all of them by clicking on the joint drop-down menu and animating each individual joint by animating the model. Great. You could do so for the slider as well. Yeah. So I hope this sort of conveys that we started with a simple 2D sketch, and with the help of a single command, the pipe command, we were able to build an entire bike frame. And using the power of bottom-up approaches, we could also bring in other components, use joints to link them together. And this is exactly how you can get started with your approach to designing. Of course, actual considerate designing takes quite a lot of time. But I think it might now be time to talk about what do we actually do once we have the CAD model. Now, let's talk about 3D printing, right? I must confess that there aren't really a lot of components on this bike that are worth 3D printing, because 3D printing is for rapid prototyping, and on a bike, we need parts that can handle high stresses in general. So what I'll do now is stop sharing and switch to my board to tell you something about what we can actually do once we have made our CAD model. Let's talk about the workflow. Okay. So you saw that we had our 3D CAD model. And for 3D printing, what we do is export that 3D CAD model as something known as a .stl file, which is just a mesh, simply speaking. And this STL file is made up of a lot of triangles connected together. Okay. Once we have that STL file, what we do is send it to a slicing software. Unfortunately, I don't have a 3D printer set up with me, which is why I can't demonstrate actual 3D printing to you. But yeah, we send it to a slicing software like, say, NetFab or Cura. The slicing software, as the name implies, takes this STL model. Say we have a cube, and it takes that STL file, the mesh, and slices it into ultra-thin layers, which can be stacked on top of each other to create our required 3D model. These layers could be as thin as 100 microns. Okay. And what this slicing software does is create something known as a G-code. You might know G-code. G-code is essentially the program that tells the 3D printing tool how to move throughout the space. And we upload that G-code to a 3D printer. And once we do that, after a few hours of waiting, we have our 3D model. Of course, we can't just 3D print anything. We have to take some considerations into account. For example, if I want to print something like the T block, I cannot just 3D print it as is, because if I try to do that, what you will notice is a bunch of depressions form like this. This happens because when the filament in the 3D printer exits the nozzle, it's really, really hot, say 200 degrees Celsius, which means it has a tendency to flow. And when you don't really give it a lot of support as such, it'll have a tendency to droop down and ruin your entire design. One way to fix this is to lay the T block on its side like this. This gets rid of the problem, or you could use supports. So I hope that I've somewhat made it clear to you how we start with designing and then take it up with the modeling. We talked about bodies, components. We talked about top down, the bottom up approach, all kinds of things. I also gave you a brief insight into how we can 3D print things, right? So I hope you've learned something from this, and this is what I had to tell you. Now I will hand over the webinar to Arjun, who will take it from here.
Thank you, Mukul, so much for those comprehensive insights on design. Like a simple 2D line and geometry concepts were made a lot of meaning, and we could see all those visually fascinating components and how you started off with fundamentals and then showed off how to actually approach it hands-on, and then what is the significance of it industrially. I hope everyone benefited from that discussion. So now that we have built our design fundamentals, we'll be moving on to the exciting and the interesting part, and what throws light upon what we do as an Allskier, right? And what we do in our company and how we innovate and how we make the best of technology. And the next we'll have Yashas talking about how to make it a smart cycle, or what I like to call it, the Allskier cycle, right? So over to Yashas, who will be talking about all the smart modules and how it can be incorporated in our design, right? Over to you, Yashas.
Yeah, thanks, Arjun. So hi guys, we meet again. Let me just share my screen. Yeah, as I hope my screen is visible. So as Arjun had pointed out, now this part will deal with adding smart devices on our Allskier bicycle, or the smart Allskier touch, you might say. Let me move on to the next slide. Now, you might wonder, why go smart? Well, nowadays, more and more people are switching to smart devices. Like a few days back, I saw an ad on Samsung AI-powered Samsung ACs. Then I saw this refrigerator that talks to you, that has an interface, LCD screen on the refrigerator that communicates with you. And there are even AI-powered fans, and AI-powered lights, which depending on your mood, which changes according to your mood, etc. Now, why do we need to go for smart devices? Well, there are 4 important points which I have found it important. So one is the obvious less power consumption. Well, now, as you can say that the coal is a major energy provider, right? Because coal in India, and India is a developing country. Well, coal is used in a major scale. And but coal, the only disadvantage is it harms the environment. It's not sustainable. So you need to channel that power consumption. You need to use it wisely. Next comes reduce utility costs. Well, that is also self-explainable, because that as less power consumption, it reduces the utility costs as well. Then there are no reliability issues, and you have a feeling of satisfaction. Well, when you need not think about anything. For example, if you want to, if there are sensors on your doors, and the sensors detect that, okay, this person is going out of the room, then the lights and fans switches off automatically. You did not worry about anything. The smart devices takes care of it all. Now let me go on to the next slide, and let me talk about the ultrasonic sensor and our Allskier bicycle. Well, what is the ultrasonic sensor? Well, ultrasonic sensor, the basic idea behind the sensor is it detects the obstacle, and basically it finds how much distance is it from the sensor, and basically triggers an alarm. I'll demonstrate a video. So now you have a transceiver module. So this is the transmitter and this is the receiver. Then the transmitter emits a sound wave and it gets reflected off the obstacle, and the receiver receives it. And the time taken is subtracted from the emission and the receiver. And that is how the travel time is computed. And you use the basic distance formula to calculate the distance of the obstacle from the sensor. And onto your left is our Allskier bicycle, and you have the ultrasonic sensor attached to the bike. Now, what it does is when the ultrasonic sensor detects any auto rickshaw or any other person or cycle coming towards the cycle and coming towards the sensor, in other words, then it triggers an alarm, and I get to know that, okay, something is behind me or something is approaching me. Well, that's the basic function of an ultrasonic sensor. Now, going on to the next slide. Yeah, I'll talk more about the ultrasonic sensor. What is the basic principle behind ultrasonic sensor? Well, as you can see over here, I have put a picture of a bat. Well, you might wonder, why have I put the picture of a bat? Well, bats are one of the animals which use ultrasonic sensing technique to detect their prey or to communicate with communicate with the surroundings. Well, it uses a basic principle called sonar. Sonar is nothing but sound navigation and resonance. Arjun, I request you to put up a poll on the same matter. So you have, which of the following animals uses sonar for communication? As I mentioned before, even in the introduction part, animals, engineers, and nature have a special bond between them. So it is also called biomimicry, as I told you in the starting introduction. Well, bats are a very good example of this. As most of you have chosen bats and whales, you're absolutely right. Bats and whales and even dolphins apparently are the ones which uses sonar to communicate between the surroundings. Now, let me so why do you need sonar? Well, why do you need ultrasonic sensors? Why this type of ultrasonic sensor? Well, this specific ultrasonic sensor, HC-SR04, has an excellent non-contact range detection with high accuracy. And one more advantage of this is it is not affected by sunlight or black material. It is totally resistant to that. And as I mentioned before, it has two components, the transmitter and receiver. Well, you might ask, what does it use to, emit? How does it emit the sound waves? Because it's all electricity, right? Well, inside the transmitter, there is something called piezoelectric crystals, which help in generating the sound waves. Well, piezoelectricity is nothing but the generation of electrical energy through mechanical energy or mechanical pressure. Basically how the piezoelectric crystal works is when an electric current is say applied to a piezoelectric crystal, then it starts to vibrate. And as you might have learned in your younger classes, that when something vibrates, it generates compressions and rarefactions. Well, that compression and rarefactions what generates a sound wave, and that is in the range of 1.5 megahertz to 8 megahertz. So that's the ultrasonic range. Now, going to the onto the left side of your screen, you can see how the Arduino, how the ultrasonic sensor is powered through an Arduino microcontroller. Now, coming to the next part of the smart system which we have applied to our Allskier bicycle is the GSM module and the vibration sensor. We're coming first to the vibration sensor. What does it do? Well, as the name suggests, vibration sensor is what detects vibration from the surroundings and triggers an alarm so that you get to know, okay, there is a vibration. Well, vibration sensors are very good at detecting even smallest of the small vibrations in the environment. And I guess if you have seen the movies that when Hulk smashes a car, it starts to beep. Well, that's the basic principle of vibration sensor. It detects the vibration and triggers an alarm. Well, you might wonder, okay, but I mean, even if I go through a pothole, it might vibrate, right? It's not necessary that there has to be a certain this one. So even for small vibration, it amplifies and gives us false alarms. Well, they have a solution for this as well. This particular module, HT45F56, which you see on the top, that is the microcontroller unit, and it is there's a magnetic coil inside the microcontroller unit, and that has an inbuilt op-amp. Well, the microcontroller unit has an inbuilt op-amp, and it is able to amplify the signal. Well, well, what is the point of this op amp is it has a preset value. So whenever this exceeds a preset value, then only it triggers an alarm. So that totally eliminates the false alarms which can give through even smallest of the small vibrations. So you can preset the value to any value so that it doesn't give false alarm. And this module, this microcontroller unit, which you see above, which you see on the right side of the screen, and which is a small module. It has a variety of vibration signal decision mechanisms, which ensure high accuracy and reliability of the vibration detection alarm. Now, on the right, what you see on the right side of the screen is a GSM module. Well, what is a GSM module? Basically, this is a Arduino compatible GSM module, and it allows the Arduino board to connect to the internet and send and receive SMS, and even make voice calls. You might wonder, oh my God, this is so amazing. This small module can even communicate with your phone through, remote places. So this is an amazing technology that we have now. And through the GSM library, this can on the Arduino IDE, which is freely available, you can code this and you can do anything with it. Now, what exactly is a GSM module? Well, basically, it's an international standard for mobile telephones, and the acronym is basically Global System for Mobile Communications. And how it communicates is through 2G, that is the second generation cellular network. And basically, the GSM, the whole module has a something called GPRS, and the SMS, how you send SMS, basically relies on GPRS. Well, GPRS is General Packet Radio Service, and it uses packet switching technology to communicate between basically the whole cycle and my mobile. And packet switching technology is through which data is sent in packets, in small packets. It's sent in groups. So that is basically the packet switching technology that we have. And integrating all this, well, vibration sensor, let me go on to the next slide. That will give you a clear idea of how it works. Well, the vibration sensor detects if there is any fall or collision with the cycle. And as I've told before, there's a preset value to that. Then the vibration sensor then communicates with the GSM module through the Arduino Uno microcontroller, which in the previous slide, as you have seen, the circuit. Then the GSM module sends out an SMS to our phone through the second generation network connection. And that's how we get to know that, okay, my cycle has collided, or my cycle has fallen down, or someone is, I don't know, someone is stealing or something, etc. So coming to the next and the final module that we have, that we plan to do on our bicycle, Allskier bicycle, is the battery powered bicycle. On the right side of your screen, you have the LCD screen, which is attached to the handle of the bicycle. And basically that displays you the battery power, or how much battery is left in the battery cell that we have on the top of the screen, which you can see. And that basically tells you, okay, this much energy I have, and have to and also it alerts you that, okay, this battery is low and you need to charge it immediately. Well, what is the use of this battery? What is the use of this battery powered bicycle? Well, let's say you're traveling uphill and you get really tired. Obviously, you guys might have experienced that climbing uphill on bicycles is very, very hard. So what our bicycle does is basically it proportionates between how much mechanical energy you apply to the bicycle, and how much electrical energy needs to be produced, so that there's a particular level according to the height of the hill. According to the inclination, it basically proportionates between the total mechanical energy and the total electrical energy that needs to be used, so that there creates a balance, and you can, without any hard work or efforts, you can go uphill. And on the left side of the screen, you can see how the motor is being attached, how the motor is attached to the rim of the bicycle, to the center of the rim. And as you can see, it looks like a normal bicycle, but this is electric. That's the beauty of the electric bicycle. And putting all this together, well, what we at Allskier do is build sustainable things and build sustainable things, also keeping in mind the economy of the bicycle, so that it is also available to the normal people, and they can buy, and they can make our world a better place, and they can live a sustainable life. So I hand over to Arjun for the final conclusion remarks.